So today's lesson on 5.5 is about finding possible side lengths of a triangle. On this one, they start off very, very simple. And we're just talking about longest sides, biggest angles, and that kind of thing. So this one, it just says mark the largest angle and longest side. Then the smallest angle and shortest side. These are actually really simple. The neat connection is whenever you find the largest angle, it's going to be across from the longest side. That's always a connection that you're going to have. Another connection that you're going to have is that the smallest angle is going to be across from the shortest side. Those will be across from each other every single time. So we have the longest with the largest, the shortest with the smallest. Well, the other ones that are left over we call just the middle ones, or medium lengths. So here's my longest, there's my shortest. So I would call this one kind of my medium length ones. And that would be kind of my mid-sized angle. So please make sure you can put them in the correct order. That's what we're going to be working on today. It'll have them labeled and we'll put them in order from smallest to largest or something like that. Theorem 5.10. Here's some inequality statements that will always be true, especially when we're on these scaling types of triangles. Says if one side of a triangle is longer than another side, then the angle opposite the longer is blank than the opposite the shortest side. Anybody find that answer? Larger. This longer side is larger than the angle opposite the shorter side. That's kind of logical. So the longer side, which they say is AB, so it's comparing these two. These are across from each other. Well, if 8 is bigger than 5, then you can say angle C is bigger than, all right, here's the other one. So here's 5. What's across from 5? Yeah, the angle A right there. So it's larger than angle A. Down here, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is larger than the side opposite the smaller angle. So now we're talking about angles, and we'll connect that with sides. So here's the statement about angles. This 50 is bigger than the 30. So you think about the sides that are across from them. This A is across from right here, and this 30 is across from here. If the 50 is bigger, then BC will be larger than, what's this one pointing at? AB. You should be good to go. So this one's pretty simple. Example 2 says, a long-tailed boat leaves a dock and travels 2,500 feet to a cave, 5,000 feet to a beach, then 6,000 feet back to the dock as shown. One of the angles in the path is about 55 degrees and one's about 24 degrees. What's the angle measure of the path made at the cave? So let's figure this out. We have a 55 degree one and a 24. Since it's already kind of visualized in this picture, which one's the 55, which one's the 24? The beach would be the 24. Okay, so some of you used some logic there. Kind of looked, which one is smaller? 24 is smaller. Yeah, beach is smaller than the dock. That makes sense. And neither of them could be the one at the cave. Why? Obtuse. So good logical skills for that. So what is the angle measurement at the cave? How can we find that angle measurement? All right, so our good old 180 trick. Inside angles of a triangle add to 180. So if we subtract those given numbers from 180, what do we get? So we get 101. So double check. Is 101 obtuse? Bigger than 90? Yes, definitely. The cave angle will be 101 degrees. Pretty simple. Try out these checkpoints, see what you can do. I'm hoping that you can get them all right first time. Read them carefully. All right, so on checkpoint number 1, it says list the sides. Those are the first 3 words. That's telling you what to do. List these sides. We're naming sides from shortest to longest. I got to find the shortest side on this picture. Which one is the shortest side? QR. And how do I know it's QR? Because it's across from the 45. That's proving it's the shortest. QR is the shortest. I need the mid-sized one. So what's the mid-sized angle? 55 is the mid-sized angle, so go across from that. PQ is the mid-sized segment. The last one is going to be the longest side. Largest angle is Q, go across from it, PR. And I think you could also see that PR looks to be the longest side. If you said RP, that would be fine too. If you said QP right here, that would be fine too. Remember segments, you can reverse the order. It's completely fine. Now down here we have one of those boat problems on number 2. It says another boat makes a trip whose path has sides 1.5, 2, and 2.5. Sketch and label the diagram with the shortest side on the bottom and the right angle at the right. So it's going to be shortest side on the bottom, right angle on the right. Your picture should look something like this. It then tells us our angles. Our angles are 90 degrees, 53, and 37. We then have our side lengths. Which one of these is our smallest side or shortest side? The one on the bottom. So the one on the bottom is the shortest. Which number is shortest? 1.5 miles. Which one's the longest? 2.5, so that's our hypotenuse. And then we have 2 miles. So your picture should be in exactly that orientation. If you have a different orientation, you're not doing what the picture says. You're not following directions if your picture is not in that orientation. Fix it now if you need to. This last one is one of the most commonly missed problems. The question that I'll be giving you that ties into this concept is this. I'll say, can these sides make a triangle? So write that down. Can the sides make a triangle? That's going to be your common question. So I'll give you 3 numbers. You tell me, can they make a triangle? So I can do like the side lengths 1, 2, and 3. I'll try like 7, 11, 12. These are 2 numbers for possible triangles. We got to figure out, can they make triangles? Well, here's the concept. The concept is the 2 smaller sides. So the short side plus the medium side will add to be greater than the longest side. So I want you to write down this. We're not going to fill in these little segment names and different things. I want you to get this right through here. Let me undo that. Pull these over to the side a little bit. Let's see. The short side plus the medium side should be greater than the long side. That's the key concept you got to get. So we can now apply that to a little question over here. Which ones are the short and mediums on these 3 numbers? Does 1 and 2 add to be greater than 3? 1 plus 2 is equal to 3. So this will not make a triangle. So what I was saying here is, can these 3 numbers make a triangle? The answer is no. When we plug these into our formula, 1 plus 2 is not greater than 3. Now the next set, is 7 plus 11 greater than 12? Yeah. So these three can make a triangle. So we are good. Here's the other type of question that you will see on the test. Right now we're given two numbers on a triangle. We're given that one side is length 14 and another is length 10. We got to find the possible lengths of the third side. There's actually a range of numbers. So we got to think of that little statement that I wrote to the side. And it was the small one plus the medium should be greater than the long one. So right now my numbers are 10 and 14. So let's think about this. If we have 10, 14, well, I could have one that's longer. Shuffle them around. My missing one, my X piece, could also be the medium, or my X piece could be the short one. So it could also be the short one. What I need to do is I need to figure out the range. How far from the short to the long? So it's going to look something like this. The range of values from the short piece to the long piece, these are the numbers I need to fill in. So how do I figure those out? Well, I plug in my formula. 10 plus 14, I'm plugging this in right here, should be greater than my unknown value. Well, what's 10 plus 14? 24. Huh. That's interesting. Let's do my other values now. Let's do these right here. So X, or my unknown, plus 10 should be greater than 14. I got to solve for X though. So subtract 10, and what do I get? 4. So here's what I do. Here is what creates my range of values. What is my range of values? Between 4 and 24. So the range of values between 4 and 24. This is how you would state your final answer. All right, so let's look at another set real quick. Here are two numbers. I want you to write out how you figure out the possible lengths for the third side. I don't want to see your final answer. I want to see your work that should match with the example I just did. So you're supposed to remember that you have two scenarios. Whenever you're given two numbers and you're trying to find the missing side, you have to set up two scenarios. And they showed it right here in two different ways. The key thing that I wanted you to remember is that the small plus the medium should be greater than the large, or the long piece. The problem is that we have only two numbers and we're missing one. We could be missing the small piece, or we could be missing the long piece. Let's figure out when we're missing the small piece. Let's plug in our other numbers. We have 17 and 23. This is a simple inequality that takes one step to solve. To get x alone, we subtract 7 and we get x is greater than 6. Now the other scenario, this is when x is the small piece. What other scenario do I need to test out? When the x is the long piece. So let's plug that in. So we have now 17 plus 23, and then our long piece out there is our unknown this time. What's 17 plus 23? This tells you your range of values, but some of you are forgetting how to write your inequalities correctly. Whenever you're writing inequalities, you put the lowest number first. So we have 6 and 40, so 6 is the lowest. And then we have a less than, our unknown value, another less than, and our large number, which is 40. That's how you write your answer properly. That's how you show a range of numbers. Will it ever equal 6 exactly? No, it's right up to it. Doesn't equal 6. Will it ever equal 40? No, it will never equal 40. It'll go right up to it. That's what you have to get in your brain on these.